Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are studying the quadratic relations part of the course. That unit is divided into two sections, and this is a review for part 1 of quadratic relations. You should have these 22 review questions, which will help you prepare for the unit test. And hopefully you have this in front of you. You've also tried all the questions, and you're just looking for some help with some of the questions maybe you couldn't get. If you don't have a copy of this, remember it's available on my Tumblr blog, or you can get it from me at school. So in this video, we're going to focus on factoring, which is actually question number 5, not question number 1. So question 5, factoring. So before we do any questions, remember, when you are asked to factor, here's what your brain should do. Your brain should first of all think, can I common factor? And common factoring includes factoring a negative from the first term if there is a negative out front. So always check for common factoring first. Once you've done that, then you can look and see what you have left. Is it a difference of squares? Is it a perfect square binomial? Perfect square trinomial? Je m'excuse. Is it a simple trinomial or a complex trinomial? So all three of these are trinomials. So that's where we're looking for something in this form. Whereas difference of squares is a binomial, where you're looking for two things that are subtracted. And other than that, if it doesn't look like that and you can't common factor, then you're probably not looking at something that we can factor as grade 10 students. So let's go ahead and look at the first question. So again, it's question 5, and 5a says, factor fully this expression. So again, always start by looking for common factors. So I don't want to spend too much time breaking everything down, but remember, this says x times x plus x. That's really what we have. So how do I common factor? Well, each term contains a single x. Therefore, I can factor out a single x. And what would I be left with? Well, that's been factored. So I'm left with x plus, well, I have to have something here. Even though I factored the x, something has to be represented by this term. So factoring is like doing a little bit of division. X divided by x, this would be 1. And remember, you can always check that you've done factoring correctly, because if you go backwards and expand, do you go back to the beginning? If you do, you know you've factored correctly. Now, the other thing I recommend that you do is if you think you're done, so I've common factored and I think I've done, I'm always going to look in the bracket to see if there's anything else that I can do. Well, that's just a simple binomial. Certainly it doesn't factor, so I'm done that question. Let's look at B. So again, the first thing we need to look at is there a common factor? So first, looking at the coefficients, I can see that 14, 21, and 35, they're all divisible by 7. So I'm going to factor out a 7. Then I can see that there's 1y, at least 1y, at least 1y. So I'm going to factor out 7y. And then let's see what will be left over. So 14 divided by 7 is 2, and I factored that y. Negative 21 divided by 7 is negative 3. I factored one of the y's, so I need that other y represented. 35 divided by 7 is 5. This was 4y, or y to the 4. I factored one of them, so I need 3 more y. So looking inside this bracket, can I factor? Well, it almost looks like a quadratic, but that's y cubed. So there's no more factoring we can do. That's the answer. Let's look at the next question. So start by common factoring. Inside this bracket, it looks definitely like a simple trinomial. Again, it's a trinomial, x squared, x, no x's. and there's no coefficient here or coefficient 1. So this is a simple trinomial. So are there two numbers that multiply to 9 and add to negative 10? So multiply to 9, add to negative 10. There they are. I've fully factored. So first of all, I'm just checking to see if I can collect like terms to simplify. I can't. So everything here is divisible by 2. X and y, x squared. So I can't common factor anything more than just a 2. So I'll factor out the 2. And what do I have? Well, now we're going to do another layer of common factoring, something called factor by grouping. And this is part of the decomposition process you should be familiar with. If I common factor these two and common factor these two, I might be able to fully factor this expression. So between 6xy and negative 2y, I'm going to factor 2y. Here, between negative 3x squared and positive x, I'm going to factor x, and I'm actually going to factor negative x because I always want to match that sign at this step. So this would give me 3x minus 1. And remember, negative x times negative 1 would give me positive x. That's why this has to be a negative sign. So it happens that this bracket matches this bracket. So factor that bracket, and I'm left with this, and I've fully factored. So again, common factoring, I can divide both of those by 5. So I'm going to factor the 5. And what I'm left with is a binomial. Now, it's a subtraction. This is a perfect square. This is a perfect square. So I'm going to factor by using difference of squares. So when you factor using difference of squares, that's when the answer is conjugates. So 2p plus 3, 2p minus 3. So the square root of this is 2p. The square root of this is 3. One bracket needs a plus and one needs a minus. So make sure you know how to factor difference of squares. They show up an awful lot, and they're supposed to be really easy. So can I common factor? Well, the only thing that divides evenly into 4 are the numbers 2 and 4, and they don't divide into 9, so I can't common factor. It's a trinomial, so I wonder if we have perfect squares. Well, we do, so the square root of 4x squared is 2x, right? So 2x squared gives me this. 3 squared gives me this. So the first and third terms are perfect squares. Now, if it is a perfect square trinomial, then what must be true is if I multiply these together and then double the product, do I get this? Since I do, I know that this is the right answer. If this was any number other than 12x or negative 12x, this would not be a perfect square trinomial. I would have to factor by decomposition if it was possible to do so. So again, just like difference of squares, be on a lookout for perfect square trinomials. They factor quickly, and they're supposed to be easy. So when I look at this, for sure I know I have to factor that negative. And 6 divides evenly into all of those coefficients. So I'm going to factor negative 6 out of everything. And again, please note that because I'm factoring a negative, all of these signs had to flip. Because when you go backwards and multiply, Negative 6 times negative 5 would be positive 30. Negative 6 times negative 14 would be positive 84. So watch when you factor out a negative, make sure you don't lose track. Now, once I factored negative 6, look inside that bracket. It definitely looks like a simple trinomial. Are there two numbers that multiply to negative 14 that add to negative 5? Sure. The numbers negative 7 and positive 2. So I fully factored. So can I common factor? Well, clearly not. If there's a 1 involved, you can't common factor. So it looks like a trinomial. It could be a complex trinomial, but look at this. That's a perfect square. That's a perfect square. So I wonder if 4x and 1 can be multiplied and doubled to give this. Well, if I make it 4x and negative 1, 4x times negative 1 is negative 4x. Doubled would be negative 8x, and that's exactly what I have. That means that this can be factored quickly because it's a perfect square trinomial, and there's my answer. Now, I'm going to do this question again because what if you didn't notice that it was a perfect square trinomial? That's fine. You're just going to spend more time, but you should get the same answer. So let's do it anyway and pretend that we didn't notice that we had a perfect square trinomial. So I would have to factor this as a composite, as a complex trinomial. So I need to find two numbers that multiply to give 16 and add to give negative 8. So what are those numbers? There's the brain, because we're thinking. Multiply to 16, add to negative 8, negative 4, and negative 4. So now I'm going to decompose that middle term into negative 4x and negative 4x. And then factor by grouping. So what's common here would be 4x, and that gives me 4x minus 1. What's common here is really nothing, but remember that sign is important. So I'm actually going to factor negative 1 to give me 4x minus 1. So this bracket matches this bracket, and what's left over is 4x minus 1. And of course, you could write your answer as a binomial squared because they're identical. I messed up my pen a little. So can I common factor? No. But maybe again, do I have a perfect square trinomial? 3x and 2. You know what? I don't have a perfect square trinomial for sure, because if it was a perfect square, I'd have to have a positive sign here because negative 4 is not a perfect square. Positive 4 is. So what do? Well, I'm going to have to factor by decomposition. So I need two numbers, please, that multiply to 36, 9 times negative 4, and add to 12. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, 6 and 6. Is there a way of getting to 12 by introducing a negative sign? So if this is negative, I have 35 or negative 35. Here I could have 16 or negative 16. Here I could have 9 or negative 9. 5 or negative 5, 0. So there's no two numbers that multiply to negative 36 and add to 12. So this does not factor. Good thing we know. Next question. J. So I know that we don't like it very much when we throw things like x4. So I want you to remember that if we do a substitution, so instead of saying x squared, we're going to use the letter a. That means that a squared would be x squared squared, which is x to the 4. So we're going to be able to use this expression, but do a substitution to say a squared minus 9xa plus 14. You almost caught me in an error. Now, this we know how to factor. This is a simple trinomial, two numbers that multiply to 14 and add to negative 9 right there. But remember, a was a substitution. So I have to put back in x squared. So I should have x squared minus 2 and x squared minus 7. So dealing with x4 is not an issue as long as it follows the pattern. As long as this is double this, it's a factorable quadratic. So this video is getting a little long. We finished at J. So what I'm going to do is I'm going to stop the video so that it's, not extensively long. And then I'll start video number 3 where I continue factoring. Okay? I'll meet you there.